Alrighty guys, today this video is going to go ahead and talk about how to graph polynomial functions, and we'll be specifically looking at some of the examples that we didn't get to yesterday in class. Remember, the objective for this lesson is students will be able to graph polynomial functions. So some stuff again that we went over yesterday to activate your prior knowledge is that when a function has more than one of the same zero, this is what we call multiplicity. And the examples that we're going to look at today are only even multiplicities. So when a function has even multiplicity, remember that this creates a relative maximum or a minimum at that zero. For example, here, my real zeros, notice that I have 1, 1, and 6. And because I have double ones, I have a maximum here at this point. Here I have a double multiplicity, -5, -5, 2, and 2 are my zeros. So at these zeros, I get a relative minimum at both of these values. Notice here on this example that none of my zeros repeat. So that's why there is no multiplicity here, and I don't get the maximums, that I pass through these zeros. So some of the examples we're going to look at. Here I have an example where I have real zeros of -6, -3, 0, and 2. Remember, your first step is to go ahead and plot your x and your y axis and scale. So if you're going to scale it, please let me know how you're scaling it. Step 2 was to go ahead and plot my zeros. So here I have a 0 at -6. 6 right here. I have a 0 here. I have one at -3, which is here. I have a 0 at 0. And a 0 at 2. Okay, so that's step 2. Step 3, go ahead and plot my end behavior. So as x goes to positive infinity, as I go to the right, my y values are going up to positive infinity. So as I go to the right, past my last 0, I go up. And here is my end behavior. And then as x goes to negative infinity, y goes to positive infinity. So as I go to the left, my function is going up this direction. Okay, and remember, step 4 is to go ahead and to plot my graph, and I'll do this in green here. So from left to right. So I'm going to go down from my end behavior through my first 0. I'm going to turn around. I'm going to come up through this 0. I'm going to turn around and go down through this 0. I'm going to turn around and go up through this 0. Okay, and there is my function. We have sketched the graph of the polynomial function given the end behavior and real zeros. Again, notice here it doesn't matter how high you come up or how low you go in these areas. For right now, we just want you to get the zeros and then the end behavior correctly. Okay. Also notice, here I have no multiplicity. Okay, none of my zeros here repeated. Next example. Here in this example, we do have multiplicity. This is an example that has multiplicity. So step 1, remember to sketch this graph given the end behavior and real zeros. I need my x and my y axis, and I need to go ahead and scale it. So I'm going to scale it 1, 2, 3, 1, 2, 3. And second step is to plot my zeros. So my real zeros are at -6. 1, 2, 3, 4, 5, 6. -4 with a multiplicity of 2. This is pretty much saying that I have a 0 of -4 and a 0 of -4. So at -4, I have a multiplicity. And I'm going to go ahead and change this color because at this 0, something different is going to happen. And then I have another 0 at 0. Okay, that's step 2. Step 3, I have to go ahead and plot my end behavior. So as x goes to infinity, as I go to the right, my y values are going up to infinity. So I'm going to put my arrow or my caret up there. And then as x goes to negative infinity, my y values go to positive infinity. I'm going to put an arrow up here. So step 4, the last step, is to go ahead and sketch my graph. And again, I'll do this in green. Step 4. So from left to right, plot this. So I go down through my 0 here, and I'm going to turn around and come up to my 0 here, but this is multiplicity. So I'm going to go ahead, I'm going to touch it, and I'm going to turn around, go back this direction. I'm going to come back up this way, through this 0, and then back up to my end behavior. Okay? Notice here, so the big thing to notice is that my multiplicity of -4. Here, I just touch the graph, it makes a peak, and then it turns around. Okay, so I have a maximum here due to the multiplicity. For these examples, for -6 and 0, notice that these real zeros, I passed through the graph. I passed through the x-axis. When we have multiplicity, we do not pass through. We touch the 0, and then we turn around, and it creates a maximum here at this spot. Okay? So one last example. I'm going to go ahead and do this one really briefly just in case anyone still has any misconceptions. Step 1, scale your graph. Plot your x-axis and y-axis, scale it. Here's 1, 2, 3, 1, 2, and 3. Step 2, go ahead and plot your real zeros. Notice here I have my real zeros are -3, right, at multiplicity, 1, and 1. These are both multiplicity. So at -3, I have a 0, and at 1, I have a 0. Next, I need to go ahead and I need to plot my end behavior. As x goes to infinity, my y values are going to -infinity. As my x's go to -infinity, y goes to -infinity. So as I go to -infinity on my x-axis, my y values go to -infinity. Okay, and lastly, step 4, I'm going to go ahead and plot this, sketch this graph. So from left to right. So I started my end behavior, I go up towards my 0, but this is multiplicity, so I touch it and then I turn back around, and then I need to go back up towards my other 0, so I'm going to come up, I'm going to touch it, turn around, and then I go down for my end behavior. Okay, and those were some examples of how to graph polynomial functions given the end behavior and the real zeros. If you have any questions, feel free to email me, and that concludes our lesson. Thank you. Have a good day.